Atoms are formed when the positively charged protons in the nucleus capture the negative electrons. Neutral atoms capture one negative electron for each positive proton in the nucleus. So, hydrogen has one electron to go with its one proton. Helium, 2 electrons. Carbon has 6. Oxygen, 8. Gold has 79. And uranium, 92. But electrons cannot just gather around in a crowd. The strange, wonderful world of the tiny has some quantum idiosyncrasies. Electrons arrange themselves in shells inside an atom like the layers of an onion. And only 2 electrons can fit per layer. So the more electrons an atom has, the further away from the nucleus the outer shells must be. And that means these electrons are more loosely held. It is this difference in how tightly electrons are held in each different kind of atom that determines the chemical properties of the element. Electrons, occupying the energy shells in an atom, take the form of a cloud surrounding the much smaller nucleus. Since only 2 electrons can fit into each of the energy shells, it is interesting to look at the characteristics of these different shells or energy states. These states are defined first by a primary quantum number called n, and also by a secondary quantum number called L. And for each state, the electron has a different energy, which results from the shape of the electron cloud. For n equals 1, called the ground state, the shape is a symmetric cloud, the same in all directions. For n equals 2, the shape can take 2 forms depending on the value of L. Although both shapes have the same energy, one shape is a double spherical cloud, one sphere inside the other, while the other shape for n equals 2 is in the shape of a dumbbell. For other values of n and L, the shapes can be pretty strange, like this torus plus dumbbell shape. The periodic table is a list of all the atoms in the universe that have different numbers of electrons. Hydrogen has 1 electron. Helium has 2. Carbon has 6. Oxygen 8. Gold has 79. And uranium has 92. Today we know that it is the arrangement of electrons inside each atom that determine the chemical properties. And similar arrangements lead to similar properties. And although each electron in the atom needs 4 quantum numbers to uniquely describe it, we only need to talk about 2 of them in our discussion of the periodic table. The quantum number n determines the gross energy of the electron in each orbital, with some adjustments for the other numbers. And the quantum number L determines the shape of the orbital. It turns out that protons in 2 or more different nuclei can sometimes capture and fight over the same electron. And when that happens, atoms of different elements are joined together to form molecules. This oxygen atom is sharing 2 of its electrons with 2 hydrogen atoms. This is how a water molecule is formed.